Hi students, welcome to Preliminary Chemistry and the water topic. And this is video number 12, looking at ionic equations. And we're going to link these into the precipitation reactions that we were having a look at in the previous video. So one of the ones that we didn't actually have a look at, but we can have a quick look at now, is when we mix barium nitrate and copper sulfate. Now we know from our rules that all nitrates are soluble, so therefore the barium nitrate is definitely going to be a soluble salt, and most of the sulfates are also soluble, and copper is not one of the exceptions. So these two are two solutions. When we mix them together, we're going to again look at what is the combination we're going to get. Here's a cation, here's an anion, here's a cat, here's an an. So we just switch them, one and one here, and two here. And so we form our copper nitrate and our barium sulfate. And from the previous video, you'll remember that the barium sulfate is the precipitate. This is actually a white precipitate. And it has formed as a consequence of the fact that the barium and the sulfate ions, when they are present in the same solution, combine together to form an insoluble substance, the barium sulfate, which precipitates out of the solution. Now this is nice, and this is one of the things that we can demonstrate experimentally in a laboratory. But when we're trying to write the equations for each of these, they can get very messy. And that's one of the reasons we want to try and simplify what we're doing with an ionic equation. In the example that we've just looked at, we can start to split up the ions into barium ions, nitrate ions, copper ions, and sulfate ions. When we do this, we can also identify what's going on the other side. We still have copper ions here, we still have nitrate ions here, but now we have formed barium sulfate as a solid, as a precipitate. The rules when we're writing our ionic equations is that we first of all write all our aqueous species in ionic form. So if the ions are in the solution, are in the water, then we write them in their ionic form. So for example, if barium is in the solution, it gets a barium 2+. You can add the subscript aqueous to identify that's in solution, but it should be in the form of Ba2+. The precipitate, on the other hand, will retain its identity. So we wrote barium sulfate as BaSO4 with a solid. Now it's not ionic, it's not still in the solution, it's actually come out of the solution as a solid, and we identify that by this notation. In the example on the previous slide, copper was present at the beginning of the reaction, and it was still present at the end in solution. So were the nitrate ions. These two ions, which were in the solution at the beginning and were still in the solution at the end, didn't actually participate in the reaction in an active sense, and so they are regarded as spectator ions. Ions that are in the solution in the same side, and the reactants and the product side are common to both sides of the arrow, if you like, and as a consequence, we can cancel them out. And this is going to seriously simplify our ionic equations. So let's just have a quick recap of that. We had originally our barium nitrate and our copper sulfate, and we produced, I'm leaving the aqueous subscripts off at the moment because I'm going to separate these in just a moment, and we formed copper nitrate, which is aqueous, and barium sulfate. And I will put the solid on that one just so we remember that it's the solid, and the rest are aqueous. So then we split them up. Barium ions, 2 nitrate ions, a copper ion, sulfate ion, producing copper ion, 2 nitrate ions, and the barium sulfate precipitate. Now, what we need to do is we need to identify that the nitrates are common ions. They're spectator ions. 2 on each side means we can cancel them out. The copper is also a common ion, so I can cancel it out as well. So when I cancel each of these out, I get left with the barium, the sulfate, and the precipitate barium sulfate. Just to double check to make sure that you haven't made any mistakes, we should make sure that we balance the atoms, 1, 1, and 4, and 4. And we should also make sure that we balance the charge. So in this case, we have a 2 plus, and we have a 2 minus. So overall, we have 0 charge on the left-hand side, on the reactant side, and the solid is not charged. So it also has a 0 charge. And so therefore, the atoms are balanced, and the charges are balanced. So this now becomes our net ionic equation. It shows the ions that have been involved in the formation of the precipitate, and it cancels out all the spectator ions. Hopefully this will be a quicker way of writing some of these reactions, and we'll do plenty of practice on these in class. Thanks for watching.